Look at numbers 13 and 14. Can you see how these two equations are different from the ones we've just been solving? Well, hopefully you notice that we now have an a term in front of the x squared, where we didn't have one before. I told you all that to solve quadratics by completing the square, we first need to make sure that our equation looks like x squared plus bx equals c. So first, I would need to add 15 to both sides to number 13. And then, to get rid of these a, I need to divide the whole thing by that a term. In this case, we divide the whole thing by -3. So we end up with x squared minus 4x equals -5. And now we can start solving by completing the square. Let's complete the square by taking half of b and then squaring it. So I'm going to add 4 to both sides here. And now let's rewrite this perfect square trinomial in factored form. So x minus 2 squared should equal -1. And then to undo the square, we square root both sides. Now wait a second. When I square root both sides, we know that the square and the square root undoes each other, so we just have x minus 2 left on the left. But then on the right side, we have to take a square root of a negative number. Is it possible to take a square root of a negative number? Well, I mean, we can take square roots of negatives, but it won't be any natural numbers. You end up with an imaginary number. So in this case, since we cannot take square roots of negatives and still get a possible solution, this quadratic has no real solutions, just imaginary ones. Therefore, that means this parabola has no zeros or no x-intercepts. For number 14, it's already in ax squared plus bx equals c form, so I just need to get rid of this 5. So we're going to start by dividing the whole thing by 5. So now we have x squared plus 4x equals 3. And let's complete the square. Half of 4 is 2, and 2 squared is 4, so I'm going to add 4 to both sides here. Then we factor. So x plus 2 squared equals 7. Then we square root both sides to get rid of that square. So now we can have our two equations. Either x plus 2 equals the square root of 7, or x plus 2 equals negative square root of 7. Last step, solve for x by subtracting 2 on both sides. So x equals square root of 7 minus 2, or x can also equal negative square root of 7 minus 2. Number 15 and 16. Again, I need to make sure it's in x squared plus bx equals c form first. So I'm going to subtract 6 from both sides. And then I don't want that a term to be negative. We want it to be a positive one. So we're going to divide the whole thing by -1 to change the sign. So we end up with x squared minus x equals a positive 6 now. And then we can complete the square. Remember, the coefficient here is actually a -1. So what's half of -1? -1/2. And then if I square this, I'd get 1/4. So plus 1/4 on both sides. And again, students, remember to work with fractions and not decimals, because you can typically find square roots of nice fractions, but not find square roots of decimal numbers as easily. Now we're going to need to factor this perfect square trinomial. What are factors of 1/4 that add up to -1? It's right here. We already found it, -1/2. So inside the parentheses is x minus 1/2. The whole thing is squared, and that should equal 6 plus 1/4. Well, I know 6 is the same as 24/4. So if I add those two together, I end up with 25/4. Do you see how 25 and 4 are both perfect square numbers? So it's going to be easy to square root this. If you are working with decimals, you wouldn't have seen this, and it would have been harder for you to square root. So square root both sides, and we get two different equations here. X plus 1/2 can equal 5/2, or x plus 1/2 could also equal -5/2. Subtract 1/2 from both sides to get x. So I get x equals 2, or x equals -3. Number 16. First, we need to divide the whole thing by 4. So we get x squared minus 7/4 x equals 1/2. Actually, I'm going to keep it 2/4. Let's just keep it 1/2. Now completing the square. Half of -7/4 is the same as -7/8. And when I square that, I get 49/64. So add 49/64 to both sides. Now we're going to factor. X minus 7/8 squared will equal 1/2 plus 49/64. Okay, so I got to change 1/2 into 64. Well, I know that 2 goes into 64 32 times. So that's 32/64 plus 49/64. What does that equal? Let's see. 32 plus 49 is 81/64. Phew. Now to square root both sides. And then write two equations. X minus 7/8 can be 9/8, or x minus 7/8 can be -9/8. Last step, add 7/8 to both sides. So I get x equals 16/8, so 2. And in this case, x would equal -16/8, so -2. Whoops, I did my math wrong, you all. 9/8 plus 7/8. Oh, it does equal 16/8. Wait, then my mistake must have been on this side. -9 plus 7 is -2/8, so -1/4. There we go. These are my two zeros.